Hi everyone, I'm Dixon, and today I'll be presenting a fascinating case of how chemometrics and near-infrared spectroscopy (NIR) can be used to predict the water content and average droplet size of biodiesel emulsion quickly, accurately, and without traditional lab work. Let's start with the conventional methods. To measure the water content, the standard technique is Fischer titration. It's precise, but it requires hazardous reagents like iodine and methanol, involve multiple steps, and takes time. On the other hand, to determine droplet size, we typically use dynamic light scattering or laser diffraction. These methods are sensitive to bubbles and sample turbidity, require sample dilution, and depends on expensive instrumentation and expert handling. So, while these traditional techniques are reliable, they are not just always efficient, especially when you need fast or high throughput measurements. This way infrared become incredibly powerful. In a study published in the journal Field in 2013 by Bumpit, Shear, and Cartihos, researchers used NIR to scan biodiesel emulsion. The spectra capture the overtones and combinations of OH, hydroxyl, and CH bonds, which are sensitive to both moisture and droplet structure in the emulsion. However, NIR spectra are highly complex and contain hundreds of overlapping signals. That's why we use chemometrics, specifically partial least square regression (PLS) to abstract the meaningful information. PLS builds a predictive model by correlating the NIR spectra, X data, which is the reference lab values for water content, and droplet size for our Y data. It reduces the dimensionality of the spectra data, identify the most relevant wavelengths, and create a multivariate calibration model that we can use to predict the unknowns. In the study, the resulting PLS models show R-square value greater than 0.95 and low root mean square errors, demonstrating excellent agreement between the predicted values and the actual lab result. That means that with just one NIR scan, we can predict both parameters in seconds with no reagent, no sample preparation, and no environmental waste. And this application perfectly illustrated how topics from our course like spectroscopy, multivariate analysis, model validation, and data reprocessing comes together in real-world problem solving. In conclusion, this case highlights how NIR combined with chemometrics offers a fast, non-destructive, and sustainable solution for biodiesel quality control. Thanks for watching.